హాయ్ ఫ్రెండ్స్, నేను మీ రాజేష్ దొంతుల. ఈరోజు మనం అయానిక్ కాంపౌండ్స్ ప్రాపర్టీస్ నేర్చుకుందాం. వాటితో పాటు యాక్టివిటీ సిరీస్, మెటల్స్ యాక్టివిటీ సిరీస్, హౌ టు ఎక్స్ట్రాక్ట్ మెటల్స్ అనేటువంటి విషయాలు నేర్చుకుందాం. అయితే ముందుగా ఫస్ట్ వన్ యాక్టివిటీ అబౌట్ అయానిక్ కాంపౌండ్ ప్రాపర్టీస్. First, collect the ionic salts, sodium chloride, potassium iodide, and barium chloride from laboratory. From laboratory, collect the sodium chloride, potassium iodide, and barium chloride salts. Okay, and take one spatula. Spatula means spoon type. Okay, first pour some sodium chloride or any collecting salt in spatula and burn with the help of Bunsen burner. Directly burn the salt. Here we observe the salt, the ionic salt melt or not. First we observe ionic salt melt or not. Okay, and also collecting samples. What is the state of the collecting samples? Ionic salt state. What is the state of the ionic salt after burning? After burning, ionic salts are melt or not observed. Next, try to all salts dissolve water, petrol, and kerosene. Which substances, which salts are dissolve water, which substances are insoluble remaining, and observe what happened. Now take a beaker. Okay, this is the battery, bulb, switch. These are wires. These two are the rods. Okay, pour some salt solution. Okay, actually salts are directly not conduct electricity. Okay, in molten state means add some water and few drops of acids add. That is the molten state of the collecting salt summa. Okay, and switch on the circuit. Bulb glow or not observe. Bulb glow or not observe. Repeating this activity, all collecting salts. Repeat this activity, all collecting salts. Bulb, in case bulb is glow, the salt is the good conductor of electricity. Bulb does not glow, salt is a bad conductor of electricity. Okay, observe what happened. Okay, next one. Here, in case salt take directly, the bulb does not glow. Salt take directly, the bulb does not glow. Okay, right. Next one, we understand that these all activities, we can generalize that the state of all ionic salts are solid state. The state of all ionic salts are solid state. So ionic substances are solid in state, but ionic substances brittle when we apply pressure, broken into small pieces. Ionic substances are brittle when we apply pressure, broken into small pieces. But between ionic substances, more stronger forces, attractional forces are there, negative and positive ions, between negative and positive ions. Next, melting and boiling point. Melting and boiling point, ionic compounds does not melt. We apply lot of amount of heat energy, so ionic substances have melting point high and boiling point also high. For example, you take NaCl melting 1074 kelvins. Okay, and boiling point 1686 kelvins. LiCl melting point is 887, boiling point is 1600 kelvins. Calcium chloride melting point 1045 kelvins, boiling point is 1900 kelvins. Next, calcium oxide. Calcium oxide have high melting point and high boiling point. Melting point 2850, boiling point is 3120 kelvins. Next, magnesium chloride melting point is 981 kelvins, boiling point is 1685 kelvins. Solubility. Ionic compounds are soluble in water, insoluble in petrol and kerosene. Ionic compounds, all ionic compounds are soluble in water, insoluble in petrol and kerosene. Next one, conductivity. Next, fourth property, conductivity of electricity. All ionic salts are good conductor of electricity in molten state. Okay, directly ionic compounds are bad conductor of electricity, but in molten state, all ionic compounds are good conductor of electricity. Okay, between these electrodes, take ionic salts are in molten state. Switch on the circuit, the bulb is glow. This is the indication of the ionic salts are good conductors of the electricity. So these four are the properties of the ionic compounds. First property state of the ionic compounds. Okay, ionic compound state is the solid state. Second property melting and boiling point. Ionic compounds have high melting and high boiling point. Third one, ionic compounds are solubility. Third property is solubility. Ionic compounds are soluble in water, insoluble in petrol and kerosene. So ionic substances are polar compounds. Next one, conductivity of electricity. Ionic salts are good conductors of electricity in molten state. Earth crust is the major source of the metal. Seawater also contains some salts like sodium chloride, magnesium chloride. The type of salts are soluble in seawater. From seawater, we obtain number of number of metals extract from seawater. Okay, sodium chloride and magnesium chloride. Number of salts are soluble in seawater. Earth crust is the major source of the metals. Okay, next one, elements and compounds which occur in nature is called minerals. From minerals we extract metals without economical loss. That means profitably extract metals. Which metals we extract profitably from minerals? The type of minerals are called ores. The type of minerals are called ores. Generally, metals are three types. Highly reactive metals, moderate reactive metals, low reactive metals. Low reactive metals all are available in free state. Low reactive metals all are available in free state like silver, gold, platinum, copper. The type of all are available in free state. But copper and silver free state available, and oxide and sulfide form also available. Oxide and sulfide form also available. So copper oxide, silver oxide, iron oxide, platinum oxide, that type of. Okay, oxides and sulfides also available. Oxides and sulfide also available. Which metals? Low reactive metals. Low reactive metals means does not participate chemical reaction, lesser participate in chemical reaction. So that type of metals are low reactive metals. Gold, silver, platinum, copper, that type of metals. Okay, available in free state and oxide and sulfide formation. Okay, next to moderate reactive metals. Moderate reactive metals, zinc, ferrum, plumbum, the type of metals. Zinc, ferrum, plumbum, the type of metals are moderate reactive metals. In moderate reactive metals available carbonates and sulfide formation. Carbonates and sulfide formation. This type of all metals we apply roasting or calcination process, convert to oxides. After we apply the reduction also. Reduction process apply. After purify, we will get the pure metals. Next to highly reactive metals. Highly reactive metals does not available in free state. Highly reactive metals and moderate reactive metals, copper available in free state, but remaining all moderate reactive metals and highly reactive metals does not available in free state. Highly reactive metals available oxide formation or chloride formation. Okay, directly electrolysis process apply, we will get pure metal. We will get pure metal. Okay, highly reactive metals apply electrolysis process. Moderate reactive metals reduction process apply using carbon. Free state metals. Free state metals means silver and copper, the type of metals, free state or native state available. Okay, next classify metals, three categories. First, concentration of the ore. After classify the metals three types: metals of high reactive, metals of moderate reactive, metals of low reactive. Metals of low reactive available in sulfide formation. Sulfide formation. Metals are low reactive available in sulfide formation. Roasting process. Okay, roasting process apply sulfide metals. Next convert to oxides. Next convert to oxides. After reduction process apply. Reduction process apply. Okay, next to purify. Refining of metal. Next refining of metal. Refining of metal. Last pure metal is obtained. Pure metal is obtained. Okay, low reactive metals available in sulfide formation. We apply roasting process. What is roasting process? Metals are burned at presence of oxygen. Metals are burned at presence of oxygen. That is the roasting process. After roasting process, okay, ores convert to oxides. Oxide source, on oxide source, apply reduction process. After crude metal is available, refining the metal, we will obtain the pure metal. We will obtain the pure metal. Next to metals of moderate reactive. Moderate reactive metals available: carbonates and sulfides. Carbonates and sulfides. Carbonates and sulfides. On carbonate ore apply calcination process. On carbonate ore apply calcination process. What is calcination? Calcination means with absence of oxygen. The ore burn absence of oxygen. Okay, that process is called, or absence of oxygen, low percentage of oxygen. Low percentage of oxygen or absence of oxygen, ore burn. That process is called calcination process. Sulfide ore apply roasting process. Already you know that. Roasting process applied. Totally convert to oxide ores. Convert to oxide ores. Okay, calcination or roasting process. Okay, convert the ore to oxides. Convert to ore oxides. After reduction process is applied. Reduction process is applied. Next refining. Last pure metal we will obtain. Pure metal we will obtain. Okay, next one, metals of high reactive. High reactive metals available: chloride, oxides, chloride, oxide, the type of. So oxide formation. Directly we apply the electrolysis process. Electrolysis process. In electrolysis process, directly we obtain pure metal. We obtain pure metal. Okay, directly we obtain pure metal. So totally metals are classified into three types. Okay, one is the highly reactive metals, medium reactive, moderate reactive metals, low reactive metals. Low reactive metals available in sulfide formation. We apply the roasting process on sulfide ores. The ores converted to oxides. Okay, next apply reduction process. After refining the metal, we will get the pure metal. Next to metals of moderate reactive. Moderate reactive metals available: carbonates and sulfides. On carbonates, calcination process applied. On sulfides, roasting process is applied. Okay, after these ores converted to oxides. On oxides, reduction process is applied. Next refining process. On oxide ores, after reduction, we will get the pure metal. We will get the pure metal. Next to metals of high reactive metals available: more percentage oxide formation. We apply the electrolysis process on high reactive metallic oxides. We will get directly pure metal. Totally more percentage of force available oxide formation, because oxygen is more abundant metal in earth crust, and oxygen have more reactive rate. Oxygen have more reactive rate. ఓకే, థ్యాంక్ యూ ఫ్రెండ్స్. నా వీడియో నచ్చినట్లయితే లైక్ చేయండి, మీ మిత్రులకు షేర్ చేయండి, ఇంకా నా ఛానల్ని సబ్స్క్రైబ్ చేయకపోతే సబ్స్క్రైబ్ చేసుకోండి. థ్యాంక్ యూ ఫ్రెండ్స్.